Okay, so this is a shorter version of. Yes, I know I'm presenting and I'm recording. Okay. So this is a slower version of going through the problems we went through today in class. So with a rectangle, you have to remember, okay, that all parts of the rectangle are congruent. So when we're looking at AE and ED, they are congruent to each other. All right, so AE equals ED. All right, so we're going to take those two variable expressions that they give us for AE and ED and set them equal to each other. A equals 10 minus 2y. Should be consistent. All right, now the second part of this is they give you BC, which is the whole diagonal. All right, so BC equals AE plus ED. So BC is 5x plus 3y plus 1. All right, and that's equal to AE plus ED, which is the two above it in the other equation, but instead of set equal to each other, added together. Okay. So now I'm going to get both of those equations in standard form. So for the top one, AE equals ED, I'm going to add 2y to both sides. So x plus 2y equals 2. The bottom one, okay, the first thing I'm going to do is collect like terms here, which is the 8 and the 10. So that becomes x minus 2y, okay, plus 18. And then I'm going to bring the x and the negative 2y on the other side. All right. So I'm going to subtract x. 5x minus x is 4x. Add 2y, so 3y plus 2y is 5y. But the y I'm going to get on the other side, so I'm going to subtract that actually from both sides. I'm going to get 17. Okay. Well, I'm going to use elimination. So I'm going to multiply the top one, the top equation, by negative 4. The result would be negative 4x minus 8y equals negative 8. And then the bottom one is 4x, still 4x plus 5y equals 17. All right. When I add straight down, which is what I do with elimination, the x's are going to cancel out. I'm going to have negative 3y equals negative 9. Dividing by negative 3, y equals 3. Nope, it's positive 9. So y is negative 3. Okay, now I'm going to take that and plug it in. So y equals negative 3. If I go back to ED, plug in the negative 3, means ED would be 10 plus 6, which is 16. All right, that's 16, which means they're all 16. So to find BE is equal to 16. All right, now the second part of today's lesson was talking about the family of quadrilaterals and diagonals. All right, and that is going to give us, starting with the quadrilaterals, it breaks down into 3 major categories that we've talked about. Okay, the kite, whose diagonals look like that. One is bisected, one is not. The parallelogram, okay, where both are bisected, but there are no right angles. And then the isosceles trapezoid we talked about. All right, the isosceles trapezoid, they're congruent, but nothing is bisected. So we got that. Now the parallelogram breaks down into two types: the rhombus and the rectangle. The only difference between a parallelogram and a rhombus is the right angle. So that's what they look like. The rectangle, all of them are going to be the same. And then if we combine those two, we have the square. And the square combines the rectangle and the rhombus. So all of them are the same, and there's a right angle. All right, the second part of this is, remember all the properties, especially the ones that work for parallelograms, since they also work for rhombus, rectangle, and square. The new thing is you need to determine what's called the truth value of a universal statement. A universal statement is all blanks are blanks. Okay? We have to determine if it's true or false. Now, the first one, all rectangles are parallelograms. If we look at our flow chart, the rectangle is beneath the parallelogram. All right? So that, ladies and gentlemen, would be true. Anytime you move up the flow chart, the answer is going to be true. All right? Now, all rhombi are squares. Now we're moving down. So that would be false. All right? And you would have to give a counterexample. So a counterexample for that would be to draw a rhombus. Now, how do you show it's not a square? Well, it can't be 90-degree angle. So all you do is label it with an angle different than 90. So let's say 80. All right. So that you have to be able to determine the truth value of a universal statement. Okay. Good. All right. So that wraps up all the notes. Okay. The next thing we talked about in class was the kite and trapezoid. Okay. Let me clean this up. All right. And then I'm going to give myself plenty of space. So I got an idea. All right. And make it cleaner for everybody. So we're going to give a page break. That's now gone. And then this is gone. Okay. So we'll start with the kite. Kite Thor, where the angle T is congruent to angle O, whose diagonals intersect at point M. Let HR equal 36, TM equal 12, and the measure of angle H equal 96. So I draw my kite. With my congruent sides. They talk about the diagonals, so I draw them in with my right angle. All right. And it says angle T is congruent to angle O, so those are our non-vertex angles. All right. And then H and R are then the vertex angles. They can be interchanged. Okay. They say the diagonals intersect at M, so I'll label the M. And then they tell me TM is 12 and H is 96. You have to remember that H is a vertex angle. So H is bisected. So that's going to be 48 degrees. It says find as many side and angle measurements as possible. So that means I got to get X, Y, W, Z. Okay. Now, if TM is 12, we know that that's the midpoint. So MO would also be 12. So we got that one. All right. 48 degrees. Not 30, not 45, not 60, and only one side means trig. Okay? So, to get y, y is the adjacent, 12 is the opposite, so that's going to give me cosine. So cosine of 48 degrees equals 12 over y. All right, because y is in the denominator, I'm going to divide 12 divided by cosine 48. By now, you should hopefully know how to do that. All right, and y comes out to be 17.9. Okay, so y is 17.9. Now, to get w, hr is 36. Y is 17.9 to get W. Oops, wrong tool. I'm just going to take the length of the whole diagonal, which is 36, subtract Y, which is 17.9, and I get 18.1. So W is 18.1. I may need that later. Okay, now to get X, I can now either use Pythagorean theorem since I know Y is 17.9. So if you're a big Pythagorean theorem person, you can use Pythagorean theorem. Or trig, X is the hypotenuse, 12 is the opposite, so I can use sine. So the sine of 48 equals 12 over X. You can pick either one. It's not going to change your answer. Again, variables in the denominator, so I divide. And I get 16.1. So X is 16.1. All right. To get the other sides of the kite, I can use trig or I can just use Pythagorean theorem. 12 squared, which is here. All right. Plus 18.1 squared, which is here, equals, we'll call it z squared. All right. So 12 squared plus 18.1 squared raised to the square root makes z 21.7. Okay. So that takes care of the side lengths. All right, that takes care of the side lengths. Now we got to worry about the angles. All right, some of them we can use properties of the kite, and some of them will go back to trig. So this is, oops, we want to do all that. So that's 48. That angle's bisected, so we know this one's also 48. A different color, so you know this is a different part. So that one's 48. Now, since we have a right angle, we know the angles on the outside are complementary. So those two angles are going to be 42 degrees. Now we have the angles on the right-hand side. For that, we're going to use inverse trig. So I'm going to look at R and realize that angle is bisected. Since I'm going to use tangent, since I got the 12 and the 18.1. So the tangent, I'm going to call it of M equals the opposite, which is 12, over the adjacent, which is 18.1. Now I'm going to go to my calculator and do second tangent. So second tangent, 12 divided by 18.1. And I get 33.5 degrees. All right. What that tells me is this little angle here is 33.5. Which means that angle there is also 33.5 because that angle is bisected. And then recall that the angles on the outside are complementary. So I'm just going to do 90 minus 33.5, and I get 56.5. All right, so those angles are both 56.5 degrees, using the fact the outside angles are complementary. All right, so that takes care of all the sides and angles. All right, so now last up is the isosceles trapezoid. Okay. So given isosceles trapezoid left, okay, where the measure of angle T is greater than the measure of angle L. Well, that means the T is obtuse and the L is acute. All right, so L, T's that way, so E's got to go that way. So now I got LEFT. TF is parallel to LE, so I'm good to go. And whose diagonals meet at point Y. All right, so what that tells us, ladies and gentlemen, is TY equals FY. All right, TY equals FY. All right, the one thing we do have to fix is this shouldn't be LY. I apologize. That should be LT. That should be LT, the last one. All right, so TY is equal to FY. So 10P minus 1 equals 6Q minus 9. All right, so those are congruent to each other. In addition, LY is equal to EY. Nope. TY is equal to FY. So 10P minus 1. LY is equal to EY. All right, so we'll work with it. LY is equal to EY. LY is given to us as 8P minus 4. EY is given to us as 2Q plus 5. Okay, so I'm going to get this one in standard form. 10P minus 6Q equals negative 8. 8P minus 2Q equals 9. All right. To me, the Q's are going to be easier to work with since 2 goes into 6. So I'm going to multiply that equation by negative 3. The result would be negative 24P plus 6Q equals negative 27. Add straight down, negative 14P equals negative 35. P equals 2.5. All right. So that means when I plug that in, since that's in terms of P, 8 times 2.5 is 20. 20 minus 4 is 16. So that means that's 16 and that's 16. All right. When I plug it into TY, 10 times 2.5 is 25. 25 minus 1 is 24, which means both of these are 24. Okay, now one other correction you got to make. FLT should be triangle TLE. Should be triangle TLE. So let's draw triangle TLE. All right, so there's T, there's L, there's E. All right, LT is P plus Q plus 12. Well, that means I got to figure out what Q is because it's both variables. So I plug that back in. If P is 2.5 and I plug it in here, this is 8 times 2.5, which is 20. 20 minus 4 is 16. I'm going to subtract the 5. 11 equals 2Q. 5.5 equals Q. So Q is 5.5 when I plug it in. LT is P plus Q plus 12. So I'm going to add these. 5 plus 5 plus 2.5 is 8. 8 plus 12 makes LT 20. All right. This segment is the diagonal. So that's TY plus YE. 24 plus 16 is, oops, hang on it, is 40. 20 plus 40 is 60. The perimeter is 100. So to get the missing side, I subtract. So that would be 100 minus 20 plus 40, the other remaining sides. 20 plus 40 is 60. 100 minus 60 is 40. I will notice that those two sides are congruent. It asked if the triangle is isosceles. Since two sides are congruent, we got a heck yeah. So that triangle is isosceles. So again, I apologize for having to go so quickly this morning, but that is an updated one that moved a little slower. If you have any issues, please let me know.